fun, here's a pun. Check out my flipped classroom. Okay, you can pause it now.
Flipped classroom basically just means you get your instruction at home and you do your homework and practice with the teacher. So I'm going to do some problems from the rest of that probability packet. That's 14 pages. The previous video was for pages 1 through 4. This video is for 5 through the end of the packet. I don't know how long it'll take, but it should be about 3 lessons or 3 homework assignments. So if you watch this whole video, you can practice as many problems in here as you want, and then when you need help, you ask me for help in the period 13 on Google Meets. And I'll send those links out on Classroom. So I'm just going to get going. So we normally start with vocabulary. Independent events. If you're independent, you don't need a lot of help from other people. They do not have an effect on you. Events that do not have an effect on each other. The outcome of one thing doesn't happen the outcome of another. So that would mean, like a lot of the examples I've already done, that I'll just take my probabilities from each event. We're calling them randomly A and B. The probability from event A will just get multiplied by the probability from event B. For example, if you find the probability of drawing a spade on 2 successive draws, one right after the other, given that the card is replaced. So in probability, you do need to know your cards. And I wrote all that stuff down on the pink Mega Note sheet that was handed out. So you are going to want to refer to that if you don't know how many cards are in a deck, how many suits are in a deck. So you got your 4 suits, what was it, 13 cards each, 52 cards in the whole deck. So the spade, spade is one of the suits. The spade's the one that looks like this, kind of like a heart with a stem. They're black cards. And again, all of this is in the Mega Notes. So the probability of I'm going to get a spade, there are 13 of those cards in the entire deck, which there are 52 cards in the deck. And if I pick out a spade, and then when I go to do it again, I put it back, then there's still going to be 13 cards, and there's still going to be 52 total. And I could have drawn a tree diagram for that, but this is like the counting principle kind of thing. You multiply, and you'll get, and correct me if I'm wrong, 169 out of 2,704, which if I wanted to reduces to 1/16. Just to go over the basics on the calculator, you want to do a fraction. This calculator is awesome with fractions. So I'm going to press the fraction button, and over D, type in 13, go down, press 52, go to the right, times, do it again, and it automatically reduces it. Older calculators will go to that answer, and then you can ask it to reduce it. If I gave you another version of this yellow calculator to take home, it'll go to this answer, and it'll give you an arrow down to say you can simplify it, and then you press the simplify button. That's if you have another version. So let's try something similar but a little bit different, because dependent events means something affects something else. I depend on this thing, it's going to have an effect on me. So if I want the probability of something happening, we'll call it A, and then something else happening, we'll call it B, and that's what this notation stands for. It doesn't mean P times A and B. It's the probability of A and B happening. I'm going to take the probability of A and multiply it by the probability of B depending on what happened with A. So that sounds more complicated than it is. So let's do the same kind of thing. We're going to take out a spade, and this time we're not going to put it back. It's important information. Words are important. So there's still 13 spades in a deck of 52, but by the time I go to take another spade out, given that I did not put that other spade back, one of these spades is gone. So that means there are 12 left. But don't forget, a spade is also one of the total cards. So now the total is smaller also. And, you know, if you're doing it old school style, multiply across. But this is a technological age, so let's just go right to the calculator. Why walk when you can drive? So number 3, determine if the two events are dependent or independent events. Normally, if I was in class, I would just say shout out I or D. Flipping tails on a coin, does that affect rolling a 3 on a die? And your answer would be no, it doesn't affect it. That's why it's independent. Drawing a jack and without replacing the card, key thing, without replacing it, drawing another jack. Well, that would mean the second time I'm going to have less jacks. And I think I just skipped one, didn't I? In any event, that one's independent. Or I'm sorry, not independent. Dependent. It changes the numbers because I didn't put it back. Drawing a 9 of hearts and rolling a 4 on a die. Drawing a 7, a card, and then after putting it back, another 7, that's not going to change the numbers the second time around. Okay? All right. So here's an easy question. If I flip a coin 2 times, be careful with the details here. If heads are on the first toss, what's the probability it shows heads on the second toss? The only thing I'm worried about is getting heads 1 time. Who cares what I did first? So what's the probability of getting heads? A half. What's the probability of you getting heads 3 times in a row? Now, this question is asked a lot. You might want to star it because I've already asked this question on a different page. It comes up often, so I do it often. I can do a tree diagram. I'm going to flip the first coin. And then after I flip heads, I can do heads or tails. After I flip tails, I can do heads or tails. And I'm doing it 3 times. So here's my 3rd row. You can do it like this with the tree diagram. You have options. It's one reason why I like math. So if I want 3, the probability of flipping heads each time on 3 tosses. So that means I want heads, heads, heads. How many of those branches are HHH? 1 out of 1, 2, 3, 4, 5, 6, 7, 8. 1 out of 8. Or there's the counting principle way. I want the probability of getting heads, and, which is times for probability, not plus like it was in other sections, and heads, and I want the probability of getting heads the 3rd time. This is the counting principle we did on the other pages. Probability of getting heads is a half, which is why when you do 1/2 times 1/2 times 1/2, you get 1/8. And I got a lot of work on this paper, so you're always going to want to box in your final answer. Okie dokies. That was page 5. Now I'll do page 6 with you virtually. Wish I could just move that over. Okay, so a marble selected from among 5 red and 4 blue. 5 red, 4 blue. Capped, meaning I'm not putting it back. And then I draw a second marble. What's the probability that both will be red? So the first thing you want to do is summarize the problem. Nobody wants to reread this forever. So what am I trying to do? I always underline the question, and the question is almost always at the end of the paragraph. So underline the question. The probability that both, meaning 2 of them, will be red. So summarize. Probability of red, and, which means times in the probability unit, probability of both. They gotta be the same. So if it was red before, it's red now. Okay? Hopefully as this goes along, it gets easier and easier. So how many red do we have? 5 red. And it's out of the total. The total is not written here. You have to do a couple seconds of work. The total is 9. Now, I kept one of these red marbles, so now how many red are there? And how many marbles are there? So that's 4 out of 8. Old school, 5 times 4, 9 times 8. Now, one of the common mistakes I just want to talk about for a hot second is that when I go back to some of this older stuff, like multiplying fractions, you don't want to mix it up with newer stuff I taught, like cross multiplying. Cross multiplying is only when I have a proportion which is 2 equal fractions. When I have 2 fractions and that's it, with an equal sign, that's when I cross multiply. This is not cross multiply. So I just wanted to make note of that for a hot second. All right, number 4, the probability that Amy passes Spanish is 60%, and the probability that she passes geometry is 80%. Assume they have no effect on each other. They're independent. Now, everything else we've been doing is a fraction. Fractions can be written as decimals and as percents, and vice versa. So, I'm going to go with decimals. Probability she passes geometry and Spanish. Probability she passes geometry and, which in this chapter is times, and Spanish. I like to summarize the question and then fill it in with the numbers. What's the chances she passes geometry? It's 80%. 80% written as a decimal. Let's say you don't remember. Check out the beautiful calculator. 80%. Enter. It's 0.8 or 0.80 is the one you're probably going to think of. So I'm going to write 0.80 because by hand you just move the decimal left 2 places. Spanish was 60%, which if you put in the calculator is 0.60. And then you multiply it across and you get 0.48. And some good review. If you don't remember how to change that back to a percent, if the question gives you numbers in percent, then you should give the answers in the same format. So 0.48, change it, triangle, change it to percent, is 48%. All right. Question B, what's the probability that she passes geometry but not Spanish? So I made up a symbol for this. So passing geometry was P for probability, and the geometry is going to go in parentheses. And then for not Spanish, I just made this up. I don't know if everybody else does it this way. I take the S and I put a slash through it. So she passes geometry is 80%. She passes Spanish is 60%. So what's the leftover percent, given that we're always doing it out of 100? So 100, take away her chance of passing, leaves her with 40%, which when I write it as a decimal is 0.40. So 80% of 40% leaves you with 32%. What's the probability she doesn't pass anything? So I'm going to use my I ain't passing slash through both of these. There's my summary. Not passing geometry, not passing Spanish. So if another thing I tried to explain, here's my 100% bar. If 80% is passed, then the leftover 20 is fail. And 20% written as a decimal is 0.20. Sorry, this isn't focused and it took so long. Okay, and then not passing Spanish, we already did that one. That's right there. Reuse what you did already. And then when you multiply that out, you get 0.08, which you can change to a percent by pressing those buttons, which would be second right parentheses. But if you're doing it, back in my day, we learned just move the decimal to the right 2 places. All right, I'm going to skip that problem on the bottom. I'm going to do a few more random questions, and this will probably be another 20-minute video. But hey, this one will be 3 lessons instead of 2. And you can pause it and copy it. I think I'm going to skip this page for now. I might go back to it later. We could talk about it on Google Meets. Try not to make the video too long. So we're just going to look at question 6 on this page. Ming rolls a number cube, tosses a coin, and chooses a card from 2 cards marked A and B. If an even number on the cube and a head on the coin appears, Ming will win. Doesn't matter what he gets for a card, no matter which card is chosen. Otherwise, LaShonda wins. So, you gotta make sure you understand your notation. Find the probability of Ming winning. So, let's rediscuss that. How does Ming win? Ming wins if I get an even. So I want probability of getting an even, and which means times a heads. And this is the shortcut method. I'm going to do it with a tree diagram too, just so you can see it. Because I did a bad thing. I kind of skipped the directions at the top. It says for each game, find the sample space, which means I'm going to have to make the list. So because Simon said so, I'm going to follow my directions, and I'm going to do that. And then find the probability. So I'm doing a little backwards. I did the shortcut first. Oh well, I'm going to show all my work. So what's the chances of getting an even on a number cube? Remember, a number cube is a die. It has 6 sides. The sides are numbered 1, 2, 3, 4, 5, 6. Evens would be 2, 4, and 6. So that would be 3 out of the 6 sides. And on a coin, you know, has 2 sides, one of which is heads. So that would mean 3 times 1 is 3, 6 times 2 is 12, and if I wanted to reduce it, Ming is going to win 1 out of 4 times, or 25% of the time. And then LaShonda is going to win all the other times. Now, listing out the sample space, you may not like it because it's a little tedious, but it's not super hard. You're going to need some room, though. There's a lot of things going on in this question. We're going to have our starting point. And they wrote number cube first, so that's what we're going to do first. If we toss a number cube, we got how many different things happening? 6. I can get the numbers 1, 2, 3, 4, 5, or 6. And that's my number cube. I like the label. Check. Did it. I'm going to toss a coin. Toss a coin, you get 2 sides. Heads and tails. I do not expect you to do things this fast. Okay. That's a little cut off, sorry. And then we're gonna flip, what are we doing? Oh, cards. There's 2 cards, so I'm gonna have 2 branches again. 2 branches. Yep, told you it was tedious. Oh well. I should pause it. Okay, so you got all your ABs at the bottom. And they didn't ask you for the tree diagram. They asked you for the sample space, which means you need to have a list. But if I don't have a nice organized tree diagram, I'm going to miss something with my list. There will be students out there who want to skip the tree diagram and go right to the list. But I am telling you, you are very likely to lose track. Math isn't all just numbers. It's teaching organization too, especially this unit. So I'm going to go through a few branches, and then I'm going to just snap my fingers and have the rest of it just show up. So here we go. Let's watch these branches and then write it down. I could roll a 1, get a heads, and 1 heads, and then an A. 1 head A, and then followed again. 1 head B. And I didn't finish all the ones yet. So 1 tail A, 1 tail B. So let's count the branches. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. There's 24 branches because it's 6 times 2, which is 12, times 2, which is 24. So when you're done with this, you're going to have a list of 24 things. Oh, Miss Roberts, why are you making me do this? Sorry. Not everything is going to be as fun as others. So let's just get that list complete. And there it is. Finished the list. All right. I think a 20-minute video is a big enough upload. So maybe I'll make another video for other stuff, or maybe we'll just take care of it all in Google Meets. All right. Bye-bye.